Keďže sa budeme rozprávať so známym britským meteorologom, respektíve on vám bude prezentovať, tak je veľký predpoklad, že v tomto prípade sa už nebudeme venovať umelej inteligencii, ale tej druhej téme Noci výskumníkov, a tou je voda. Voda k sebe nabaluje absolútne všetko, to znamená, že toto by pokojne mohol byť námed. A ja som veľmi rád, že to moderátorské žezlo teraz odovzdám ďalšiemu pánovi, ktorý sa volá doktor Nédlik, je z Ústavu vied o Zemi Slovenskej akadémie vied, ktorý bude viesť celú tú konverzáciu s pánom Scottom Duncanom.
Thank you.
Dobrý večer. Good evening, everybody. The next presentation will be about the change. We know that there is nothing stable in our universe. The only what is stable is the change itself. And those of us who experienced 60s, 70s and 80s in the previous century, we can feel some change on our skin. It's the change of climate. And it's our feeling, but it's not that much easy to see it. And there are people around us, some specialists who would like to make it visible for us, to make a second plastic picture of what is going on regarding the climate change. One of them is a British senior scientist, British senior meteorologist, Scott Duncan. He was raised in the Scottish Highlands and he experienced very severe weather events, different kind of weather extremes, and this brought him from the childhood to the interest about the climate and weather. After the studies, he was involved in different type of weather industry, including developing the weather forecast website. This also a certain visualization. And now he's gonna to bring us a certain picture what is going on now. After some time, in the recent time, he changed his attention and he put his attention to improve the communication of climate and weather events, climate and weather issues, to make it more visible, more understandable. So please, Scott, the floor is yours.
Good evening, ladies and gentlemen, and welcome, and thanks for joining me on such a late, lovely evening in Bratislava. So happy to be here in such a beautiful country. I'm actually from Scotland. I've already been introduced, and Scotland and Slovakia are actually about the same size when it comes to population, although the weather here is slightly better than what we get back home. But anyway, that's not what I'm here to talk about. I'm talking about visualizing our warming atmosphere and oceans. I've always been interested in the weather from a very, very young age, all the way from the Highlands of Scotland, as mentioned, from blizzard conditions, storms, and then I turned that into a passion that I took into university. I studied at the University of Reading, and then also went to study in the University of Oklahoma out in the USA and chased some tornadoes and saw really what nature really had to offer us. So I'm a massive weather nerd, absolutely love weather. But more recently I've been turning my attention to improving communication, in my opinion, the kind of key aspects of weather, but also climate, because it's a very important matter. It's something that I've become exposed to through my passion, and that's what I'm here today to talk about, is visualizing our warming world using some of the graphics I often share on social media, but then also trying to communicate something that people can take home and talk about. So this is what I'll be talking about today. First of all, I'll talk about the vital signs of planet Earth. So if you're a patient, you went to the doctors, you want to see what's going on, you want to go and check the blood pressure, you want to check the heart rate, do a basic check. Let's look at what's happening and what kind of data we have. And let's put it on a big screen at this amazing arena with amazing graphics. We'll also be using, hopefully, that big globe later today as well. Looking at the future as well, so climate's very important to look at the past and also then the future, looking at the consequences of some of the changes we'll be talking about, and then maybe looking at some of the technology we have in weather and climate. There's a lot happening in weather and climate right now. Actually, weather and climate have had an AI moment. A lot of artificial intelligence has been talked about, ChatGPT, lots going on. It's making its way into weather forecasting, and it is very exciting. So there's a few things we can talk about there as well. So I'll try and cram that all in the next 30 minutes or so. So before we kick off, though, let's talk about why weather and climate is important. Why should we even care about weather and climate? Because I mean, it's a beautiful evening here in Bratislava. I mean, I'm actually a little bit warm in my jacket, but if it was raining a lot outside, maybe we need our umbrella, maybe we need our jacket. Today, it's not such an issue. It's something that can impact us on a day where, for example, if it was going to be more extreme, then you might want something that would keep you warm. If it was going to be cold, for example. But sometimes it's better to look maybe a bit further away from where we are today and what we're wearing, for example. That's just kind of the tip of the iceberg. It's also good to think about, well, where did our food come from? How did it grow? Where does it come from? Did it have to use transportation? These things are all impacted by weather. I used to forecast for the transport industry, not the transport of food, but the transport of people. And there's a lot of things that can impact the travel industry. Rain, wind, thunderstorms, snow, everything impacts the travel infrastructure. Even warm temperatures, hot days can actually impact it. So we should care about it, and some days it impacts us more than others. So whether we appreciate it or not, if we're working behind a desk or if we're working out in the fields, the weather impacts us whether we like it or not. So we should care about it. Anyway, climate. What is climate? What's the difference between weather and climate? Well, anyway, climate is basically like taking a lot of weather, averaging it over a longer period, and kind of packaging it up. So what's the average temperature in Bratislava in summer? What's the average temperature during the night? How much rainfall does it get in a general longer period? So it's different to weather. It varies more slowly. It is something that basically summarizes the lots of fluctuations we get on day to day. So climate's not something we experience. We don't walk out and say, we got a climate shower today. It's not the same. So there's a big difference, and there's actually a bit of an overlap when it comes to attribution, but we'll talk about that later. Weather and climate are very different, but if things start to change in climate, things may be changing, getting warmer or colder, how does that impact the weather that impacts us on a daily basis? That's when it really starts to hammer home. Does it impact the extremes we get in our weather? So that's where things get important. So we should care about weather and climate. Humans are creatures of habits. We love stability. We like it when things stay the same, when it comes to farming, when it comes to our daily lives. It's familiar, it's routine. If things are changing in the background, we should know about it and we should care about it. So I'm just going to jump in now and show you a graphic behind me of the last 140 years or so of temperature data from across the world using some NASA data live visualizations here. So don't worry, this graphic will repeat a few times. It will just keep going and I'll just keep talking. So on the left here, you've got the global average temperatures on a map, and basically what's being summarized on a graph on the right. And when it comes to communication of weather and climate data, I think it's really, really important to kind of put the two next to each other. Sometimes graphs are very, very important. This graphic here on the right, kind of showing the numbers in a striking form of visualization. But I think sometimes putting it right next to what it's actually summarizing on a disk of the whole globe is really quite powerful. It's quite impactful. And you can see as we go through time, things are turning more from blue to red, and unsurprisingly, that does mean that the world is gradually warming. So this is from 1880 all the way to 2022. Obviously, 2023, we're only in September, so by the end of this year, we'll have a new image to add at the end. And you can see there's a lot of fluctuations. If you look into Europe, for example, you will see there's some blue years, there's some red years, there's some white years. But overall, there's quite an overwhelming trend to the redder side. So that is climate change. That is global warming. We are moving from a cooler episode and moving into a warmer future. And you can see that from the graph as well. So you can see on the graph that that is basically taking the whole globe, taking all the data in that, packaging it up quite nicely and putting it as a bar. And if it's warmer than average, which in this case is the average air temperature between 1950 and 1981, it will go down as a blue contour. And if it's warmer than that base average, it will be red, and so forth. So you can see there's a bit of variability year to year, but there's quite a clear warming trend as we go through time, especially since the 1980s. But we'll talk about that again a little bit more in detail. So if we then start to zoom in, that's great. That's a whole year of data. Let's look at a month of data. In every year, there's obviously 12 months. So since 1880 all the way to present day, actually, I think this finishes in about July 2023, you've got every single month. There's obviously quite a lot of spiking around, bit of variability year to year, warmer years, warmer months, cooler years, cooler months, fine. There's quite a clear warming trend. So that's basically starting to zoom in a little bit more. You could actually then go into daily detail. You'd have a lot more graphics to plot there, so we're not going to go into that level of detail, but that's fine. But sometimes I think in this type of situation, there's a clear warming trend. It's quite smooth. what if we take one period and then compare it to kind of more recent times? So let's take summer 2023. The ink is still drying on this map. It was made literally summarizing June, July, and August. Obviously, in this globe, summer represents the northern hemisphere. In the south, it's winter. But we're in Bratislava, we're in the northern hemisphere. We're going to call summer June, July, and August. The reason I've chosen 2 years here, 1936 and 2023. 1936 was a very, very important time for especially North America. You can see North America was at the epicenter of a very large heat anomaly. It was part of the Dust Bowl days, so it was part of a time where there was a lot of heat records. Some of the most profound heat records in US American temperature history still stand from that summer. Comparing to the summer of 2023, you can see actually North America on its own, around the USA, okay, it's warm. It's not quite as hot as the 1936, but look at the rest of the globe. Sometimes it's good to kind of look at a heat episode in the past, but then zoom out and look at the global picture. I think that's a really key part when it comes to visualizing what's going on. Because I think sometimes weather and climate, we think about what's going on around us in a small area, maybe our back garden, maybe our own country. But when you kind of zoom out on a global perspective, you can sometimes see a bigger trend or something that's bigger than what we see ourselves from our own back garden. So I think that's a good way of kind of looking at the latest data, is putting into perspective and using these kind of past events and putting them into kind of modern times, and you really see it. But that's fine. So that's looking at some heat episodes in the past, putting on a global scale and saying, well, okay, background trend has warmed. But I've only been showing data so far since 1880, but let's look further back. Okay, so using some of the most recent data, again from NASA, here looking back to the last ice age about 20,000 years ago, the planet has obviously warmed up quite a bit. We're not under meters of ice or kilometers of ice for some. We're in quite a kind of habitable part of time. But it's this last 140 years here, you can see from far end of the graph here, this red spike. It's basically all the graphics I've been showing so far has been all put into that last 100 and 140 years or so of data. So that's where kind of time perspective is really quite important as well. So it's also zooming out, looking at a global picture, but also looking at time perspective. So we've warmed up very quickly in a short space of time. So fine, the world has always gone in and out of ice ages. It's always changing. There's many good reasons for that, including the sun, volcanic activity. In the last 140 years, 200 years, there has been a lot more from human contribution. Again, I'll talk about that more in a bit. But you can see, putting that last 140 years of data into perspective, you really can see quite a striking change here. So what I'm going to try and do is send over to the IT team to kind of put that 140 years of data onto the globe. I don't know if it will happen, but it'd be really good to see that same data I've just been showing and pop it onto the big globe here. So this is also fresh from NASA, from the 1800s, rolling through to present day. So the blues are showing cooler than average temperatures, oranges and reds are kind of showing warmer than average. And an average in this case is basically taking a 30-year period between 1950 and 1980. So kind of mid-20th century. If it's blue, it's cooler than that base period. If it's warm, if it's red, it's warmer than that base period. And as you go through, we're already getting to the 1930s. If anyone from the top row can see North America, you should see a few hotter years appearing there, back to the blues in the 1940s. And as we crunch through time, you'll see things kind of going from blues to whites to the yellows, and we start moving towards the red. So this is the same data set I've been showing from NASA, and it's really exciting to see it on an actual globe and not just on a graphic flat on a page here. So that's how things are looking on this globe. So you can see things are turning more to oranges and red, especially since the 1980s. We have seen quite a profound impact here. And we'll come back to this next animation here, which goes into the future, spoiler alert. Anyway, moving on to the next slide here. That's fine, we talked about air temperatures. Let's look at the oceans, because the oceans are so important. They can store a lot of heat. For example, you have a bathtub. It can stay warmer for longer than your air temperature. It's basically like a battery when it comes to heat. So when you warm up the atmosphere, what happens to the ocean? I've got a little black box here circled in a square in the Pacific. I'll look at that in just a moment. It's the same sort of idea, though. The oceans are warming up along with the air temperatures, and it's quite a steady progression. The heat content is increasing as we warm our atmosphere, But you can see in this black box here, it's a very important part of the world known, as an ENSO box, where you have your El Niños and La Niñas. For example, 2022, last year, we had quite a strong La Niña, basically a cooling of the equatorial Pacific waters in this box here. So even though the whole world is warming, you can still get these oscillations from blues to reds. But you can see from the background warming trend that the whole globe is still gradually warming. And this is the graph on the right here is showing basically the average temperature, but then labeling those years depending if they're El Nino, if it was a red box, or a La Nina, if it was a blue box, and kind of going through time. So 1997, 1998, there was a big spike in reds in that box. That was a very strong El Nino. 2015, 2016, again, also a big red spike. The last few years, including 2022, were La Nina. It was on the blue side. So basically, El Nino, La Nina can give a bit of a kick to our global average temperatures. So it's good to look at how El Nino and La Nina impact our global average temperature, but it's also very good to kind of look at the longer term trend. Even though we do have these oscillations, there's still quite a clear trend overall there. So that's how the ocean data is looking, but that obviously stops at the end of 2022. If anybody's been following the news recently, 2023 has been something quite extraordinary. So I have made a graphic here kind of showing how things look in 2023, from the 1st of January actually, with using some satellite-derived data here. And you get rid of your blue in the equatorial Pacific, this La Nina, just off the west coast of South America, turns to red. But it's not just this part of the world which is turning red. The North Atlantic, North Pacific, global sea surface temperatures really are out of the textbook when it comes to climatological records here. You've got the graph here from Climate Reanalyzer, free data source. I do have a link of sources at the end here. The black line here is kind of stacking up the sea surface temperatures of the world and then comparing it back to some modern records there as well. So really quite striking sea surface temperature trends in the last year. So we do have an El Nino, so we've got rid of our cool equatorial Pacific water off the west coast of South America, but we really have gone into quite an unprecedented era for sea surface temperatures across the world, and that is having quite an impact on the air temperatures as well, and there'll be more and more headlines as we go through. Wouldn't be surprised at all if this is our warmest year on record for the entire globe. Not saying warmest year on record for Slovakia in particular, but the whole planet as a whole, it really is quite a striking trend that we're seeing here. So obviously the elephant in the room is like, well, what's going on? Let's look at what kind of things have changed in the past. So, well, one of the big things is the greenhouse effect, climate change. The drivers behind that is what goes on in the atmosphere. It doesn't just stay in the atmosphere. It's what we put in the atmosphere that's really important. And looking back using ice core data and other instrumental records, and then comparing to modern day carbon dioxide trends, you can really see how things kind of shape. And this is not just 100 years of data or 500 years of data. This is 800,000 years of data. So it's a very long-term trend. The way we've used fossil fuels to kind of build up society, it's something that has an impact on the atmosphere. And that's what we've seen really spike. And it's not surprising that we're seeing quite a reaction in temperatures across the world, not just the atmosphere, but also the oceans. So now I'm going to start moving in towards impacts of this climate change. And I think one of the best places to look, or the most clearest places to look, is in the Arctic. So this is it's probably an old statement. The Arctic is warming twice as fast as the rest of the world. Is that true or false? Well, the answer is actually, it's false. It's actually quite a bit faster than that. So this is a graphic going up to 2020 using, again, NASA data looking just at the Arctic and then also the global average trends. So the red graph is showing the temperatures just in the Arctic and how that compares to the global average. So you can see the global average temperatures, yep, it's increasing. We've seen that already in the graphics, talked about that already. In the Arctic, though, it's changing quite a bit quicker. And the graphic on the right here is showing the average temperature from 2020. You can see there's quite an epicenter of significant warmth, relatively speaking, for the Arctic in that year. And it's not just that year. We're seeing that year on year. This is changing very, very quickly, and there's a very good reason for that. So the reason behind that is called Arctic amplification. And this is where things that happen in the Arctic don't just stay in the Arctic. So I'm going to kind of link this back to Europe in just a minute, but don't worry. So looking at Arctic amplification, if we have a warmer atmosphere, like we're seeing, that's fine. We've seen that already. What does that mean? Moving on, it melts more sea ice. So when we melt more sea ice, what does that mean? Well, it exposes more water. So when you've got water in the Arctic instead of the ice. The ice is obviously very different to how water is. Water can absorb the energy instead of reflecting the sunlight back to space. Obviously, the Arctic gets a lot of sunlight during the summer. In the winter, it's very, very dark. So we're talking about the summer here. The ice is able to melt. It exposes more sea. That sea then absorbs more of that sun's energy, kind of putting it in quite a basic way. That means, we've already talked, ocean surface absorbs the energy. We've covered that. So ocean becomes warmer, unsurprisingly. So what happens when we warm the ocean? Well, that then melts more ice. So it's already starting to set up a bit of a vicious cycle. So when there's more melting ice, what does that mean? Well, there's more surface that's then becoming exposed for the sunlight to come in and then heat up the atmosphere and also heat up the water. So as you go around it, you can see we start to get into this vicious cycle. More warming leads to more melting, which leads to more warming, which means I could keep going on and on. But anyway, there's a bit of this vicious cycle, and that's why the Arctic's changing quite quickly. And it's not just polar ice that's being impacted here, but this can also impact weather circulations as well. We'll talk about that in just a minute. But let's look at some more graphics summarizing that. This graphic here, actually on the left, is by a fantastic scientist called Zachary Leib. Got a link towards his stuff at the end of the presentation. Very much worth checking out his stuff, visualizing his graphs and animations. You can really see how things have changed. So this is 2023, and then kind of looking at that, how it stacks up versus the last, the data that we have versus satellite records. This particular data set goes back to the 1980s. On the right here, you can see, taking the 13th of September, we normally see about the minimum sea ice extent around this time of the year. So 2023 was about the 6th lowest on record. The orange line that goes round is what would normally be the minimum extent between 1981 and 2010. So between that kind of 30-year period, that's where the ice would normally melt to. We're obviously seeing that kind of retreat quite a lot more. So we're expanding the ocean in that area. We're seeing a lot more extra heat basically hit that surface of the ocean where it would normally be ice. So it's changing the dynamics in the Arctic, and that's Arctic amplification, and that's what's going on. So, well, that's fine. We've looked since the 1980s. We've got some data sets here, but let's look at some reconstructions that go further in the past. Again, using some of the work from Zach Leib. The recent trends here in Arctic ice extent really do kind of ring through. It's quite striking here. The extent in million square kilometers, where we're talking about not just the size of a football field or just the size of this room. We're talking about very large areas. And actually, this way of looking at it, I think this is quite a good way of kind of putting them next to each other. So let's take an average year between 1981 and 2010. There's a bit of variability during that period. Normally you get to this sort of extent, 6.3 million square kilometers. That's a big number. I don't know exactly what that looks like from space, but now I do. That's what it looks like. 3.7 million square kilometers was missing in 2020 compared to that average time. So let's put that into real numbers. How many Slovakias could we fit into that missing area of ice? And I did a bit of a back-of-the-envelope calculation using quite a Google search on area extent of Slovakia, and it came to about 53 Slovakias could fit in that area. So basically, we're changing the dynamics of what's coming into the Arctic. It's hitting now water instead of ice. 53 Slovakias, and that's obviously quite striking, in my opinion. So that's another way of looking at how things are changing in the Arctic. This is was extent, but obviously the ice is also, it's got a thickness, it's got a volume. This graphic here also shows that the deeper, older ice is also starting to deplete as well. So this animation kind of puts that into perspective as well. So the brighter the colors here means the ice is thick, and obviously as you go through time, you're starting to retreat that, and you can see it from the graphic here. And the sea ice volume here, overall from the left, gradually declining as well. So the Arctic ice is not just changing in its extent, it's also shrinking overall. So it makes it hard for it to reform in the winter. So sea ice loss, another way of looking at it, again, just taking a snapshot in the past and then looking at a more recent time, 1980 versus 2020. You can see from the graphic here, you got 30,000 kilometers cubed of ice during the winter months. You're not reaching the same depths and volume as you were in the past. And then the summer months and late summer months, especially as you go towards September, October, really kind of starting to shrink overall here. So this is another way of looking at the same data. That's fine, we've talked about the Arctic, but obviously we've got the Antarctic as well. So let's kind of zoom out and look at global sea ice. And 2023 has been quite profound, not just for the Arctic, but in the Antarctic, actually especially in Antarctica. It's a place that's been quite immune, apparently, to some of the warming trends of recent years, but 2023 we've seen quite a striking decline in the sea ice extent here. There's a lot of anomalous heat in the oceans. The ink is still drying on some of the research that's looking at 2023, but it really is standing out to be quite a remarkable year and quite a striking year for lack of sea ice, heat content in the oceans and heat extent in the atmosphere as well. So it's not just the Arctic. The Arctic is where we're seeing some of the biggest changes, and it's closest to us obviously here in Europe. So now kind of moving into impacts here, I've managed to cover the last bullet. Anyway, so we've talked about polar ice loss. I'm mentioning glacial ice loss as well, because that is also very, very important. So polar ice in the Arctic is actually floating on top of the water. And if you think about a gin and tonic or a Coca-Cola, and you've got your ice in your drink, if that melts, it doesn't overflow. It doesn't fill up the glass even more than that's already there. The water that's in the ice, actually when it melts, doesn't have a huge impact on the level of the water it's in. It's the land-based ice that has quite a bit more impact. So there's a lot of glacial ice in around the Arctic. Greenland, for example, these are also kind of in line with the Arctic amplification. We're seeing more melting of land-based ice as well. So that takes me on to the second bullet point here, sea level rise. So the sea level has been fairly stable for the last 8,000 years or so, but in the last couple of hundred years or so, we have started to see it rise, and it's a bit of a lag effect when it comes to temperature. When it comes to temperature, you do see a bit more of an increase, and you see the impacts quite quickly. The sea is like a slow-moving body, and it is moving a bit slower, but it is starting to rise as well. This year, we have had, again, we've talked about 2023 is quite an impressive year when it comes to heat content in the water. We've had very, very impressive marine heat waves. We don't just get heat waves on land, we also get heat waves in the ocean, which actually can be very damaging for ecosystems that thrive in a very specific environment when it comes to temperatures. So I've shown one here from earlier this year in June. We actually had our warmest June on record in the UK. We've got temperature records going back to the 1600s, which is 400 or 500 years. It's a very long temperature record. We broke that record in this June. The sea temperatures were extraordinary. We were seeing kind of 18, 19 degrees sea surface temperature. That doesn't sound like much when it comes to sea surface temperatures. You go to the tropics, it's much warmer. For the UK, trust me, I've swam in the North Sea before. It was very, very impressive. It was very warm. When you get these marine heat waves in places that are a bit more fragile when it comes to the Mediterranean, we can see more kind of catastrophic impacts, coral bleaching, and kind of shallow water ecosystems can really be kind of at the detriment of these marine heat waves. So we're seeing an increase of marine heat waves as well. So coral bleaching kind of ties into that point. That's just one of the kind of main ones we're looking at. Changing weather patterns. So the way the sea surface's temperatures were impacting the lower atmosphere, the weather patterns that we're seeing, they can actually work together to kind of emphasize or even punctuate some of the extremes. I've used this graphic from September. Actually, Northern Ireland here managed to record one of its warmest September day on record. 28 degrees for this part of the world is very impressive. And we're also seeing some record-breaking temperatures also this late in the year for Slovakia. I mean, I think when we go into October, we're going to be seeing records being broken across Europe here. It's very, very warm. And the sea surface temperatures kind of impacting the atmosphere is all part of that. So weather patterns, weather extremes can also be impacted, kind of going hand in hand with those changes. So going back to the question of why should we care about weather and climate? So there's obviously some impacts going on here, but we've not kind of brought it closer to home. So we've talked about the Arctic, we've talked about long-term trends. There's 267 million people that live on land less than 2 meters above sea level. We're in Bratislava, we're in Slovakia, we're nowhere near the sea. So this is not the easiest pitch, I guess, when it comes to talking about sea level rise. The sea level would have to change a lot, and that's not in any of the projections, but there's a lot of people that do live near the sea. And when we talk about weather impacts and then kind of bring them closer to home, things that happen far away can still impact us. We can look at transport infrastructure or where our food comes from, these sort of things. Where we go on holiday, for example, that is also important. The kind of globe is now connected using technology, society infrastructure. We're all kind of connected as well. So a lot of people live near the sea level is rising. Almost 2 billion people rely on glacier and snowpack as the main source of drinking water. In Europe, we've seen a very large shrinking of glaciers in the mountains. If anybody has visited the Alps in recent years and managed to observe what's been going on in the glaciers in the Alps, there are very striking changes. There's literally photographic evidence year on year over the decades showing how things are changing. And if the glaciers are not there anymore, what does that mean for drinking water or kind of water supplies downstream? We're not just talking about drinking water. Those rivers are important for other things. People use those rivers to get, for example, coal barges in to supply countries with energy. It's a very important part of society when it comes to water. So glaciers act like a buffer. It's stable. If you take away those glaciers, things become more erratic. We don't like that. We're a society. We're humans. We love routine. We love rhythm. If things start to change and become more erratic, it's harder to predict when it comes to making decisions, and society can really suffer as a consequence. So snowpack, glaciers, it is changing in the background, and a lot of people rely on that. So that's why we should care. 2 billion people already don't have access to safe drinking water, and that's, again, taken from the UN here. It's something if rainfall patterns are changing from these warming patterns as well, it's something that can have quite an impact in large parts of the world. So that's a very large proportion of the world population. So going into society and future, we'll be using that globe shortly, but before I get there, society and future, growing importance of weather and climate information. And again, this is what I'm really passionate about. It's kind of showing what the weather's doing and putting it in a way that's very, very clear and can be communicated in a way. And people can then react in a certain way. For example, we've had massive flooding in New York just today. You might even be able to open your news channels right now, and it'll probably be flooded, quite literally, with quite shocking images from New York. If you opened up your phone right now and then could go back one day, and then you wanted to tell that New Yorker, what would you tell them to make them be prepared for that sort of day? Weather and climate information, like we have very powerful weather computers. This graphic here was actually simulating Hurricane Lee as it approaches northeast Canada. The weather models had this days in advance. Like meteorologists are looking at that, they're communicating it calmly, people can take the right precautions, people can react in a very meaningful way, life-saving information days in advance. So society and future, there is more and more reliance on technology, and it's powerful and we can use it, and that's what I'm really excited about. And using all this technology here to kind of help communicate that really is quite something. So that's the first point, attribution and communication. So weather is one thing, communicating climate is another. So if you get a thunderstorm, was that climate change? Well, no, not necessarily. Like we've had weather, we've had extremes throughout past. That's where communication of extremes, is it just run-of-the-mill extremes, or is this something that's becoming more of a trend? This is where scientists trying to use more meaningful methods of communication kind of help attribute the changes in climate. What does it actually mean? So this is kind of like where we all become our own kind of forensics here. Being able to access the data ourselves, look at it, play with it, it's all open source. It can really make us more powerful as individuals. There's a lot of information out there, some of it's good, some of it's bad. When it comes to attribution and communication, this is where people, if everybody had more awareness, this is where I think the future will be when it comes to weather and climate. So I think that's a really big part when it comes to climate change, is attribution and then communicating what is and what's not and how much do we know. There are still some uncertainties. There's challenges and uncertainties. That kind of takes me on to that point. Anyway, there are uncertainties, there are unknowns, and it's not an exact science. I can't tell you if it's going to be 14.5 degrees in Bratislava on the 12th of November. We're not going to pretend that we can do that. But we may be able to say, using AI, I'll be talking about that in just a minute, be able to say something more broadly about winter. Is it going to be snowier than normal? Is it going to be wetter than normal, drier than normal, warmer than normal? How can we use that information to help also predict future climate? So there's a lot of uncertainty, there's a lot of challenges, but this is where it takes me on to the last two bullet points here, opportunity and technology. And I think this environment here, if you've had a chance to look around some of these stalls here, it has been, well, it's remarkable. I'm wanting to look at more of them, to be fair. The technology really is leaping and bounding forwards, and it's not just AI. It's making its way into very different parts of our world, and that includes weather and climate. So there's opportunity, there is technology. But anyway, let's look at the future. So I'm going to point over to the globe again. So I've got a graph behind me, which is showing the future projections from the latest CMIP data from 1850 and all the way to 2100. So obviously we're at the year 2023. We've got different scenarios using these weather models, taking past data, using the latest cutting edge technology, and then rolling forward. And the global average temperature continues to rise, and there are different scenarios depending on how we act as a society. So depending on how we reduce our carbon emissions and greenhouse gases, we have these different outcomes. So we're not going to stop the world warming overnight, but actions taken now will impact what we end up with in 2100. And we're already seeing quite big differences. This, again, is the global average temperature. This is not talking about individual countries. It's not talking about the Arctic. there's a lot more variability when it comes to zooming in on the planet. So what I'm going to do is just pass back over to, hopefully, the IT team to run the projections into the future from current day all the way into 2100. But if not, we can move on to artificial intelligence and talking about weather. Oh, here we go. So, we're already in the future. So we've already kind of come from the 1800s. We've run through to present day. We're already at 2030. Things are warming up. The planet is continually turning more towards these origins in red. And looking at the axis here, this is, again, paying very close attention to the details on the axis. So, like, what is red? That's 4 degrees warmer than the average. And again, different parts of the world, if you're on the top row here, around the top, you'll be able to see different parts of the world are warming in different ways. Might not be able to see Antarctica with the globe on the floor, or you might not be able to see the Arctic, but I can tell you the Arctic is warming more than other parts. Most people here will probably just see a massive portion of Australia. But this is now at 2077, I should say, 2080, and this goes all the way to 2100. And in the current projections here, using the cutting-edge technology, which is improving literally by the day, we are continuing to see things warming. Oh, you can actually see the flat version behind me, which I didn't realize. Yeah, you can see the Arctic really is kind of at the epicenter of changes overall here. So that's brilliant. Thanks very much. So, technology, I've been talking about that on and off. Well, artificial intelligence, I've been working as a weather forecaster now for a number of years, and people are getting pretty smart about the weather. And people are using still the weather models, which rely on supercomputers currently, but they're running simulations and kind of back tests and creating new versions of the model, and even the ECMWF here. This is all linked at the end of the presentation here. Pangu, weather machine learning, weather model. I was watching how these did at forecasting the hurricanes, and they were pretty good. So they're running at, well, they're using the data from ECMWF. They're also then running all these different simulations, but they're at the fraction of the cost of the supercomputer. So they're providing all these extra scenarios, all this extra data for us to look at, almost too much data, in my opinion. But there's a big movement in artificial intelligence. That's just in weather, but climate, there's a lot of extra information we can get out of the computers here. The bottom graphic here is actually our latest track of where the hurricanes are going to go over the next few days. So yeah, I can actually see we've got still quite a lot of tropical activity. Some of the ex-hurricanes might end up next to the UK. That means it's going to be pretty warm here for quite some time on the continent. So Slovakia, it does look like it's going to be staying pretty warm as we head into October. I wouldn't be surprised if we're pretty much as warm as we've ever seen it for the month of October. But anyway, artificial intelligence in weather and climate, it really is moving, and it's very exciting. There's a lot of opportunity in it. And I'm not an AI scientist, but it's something I'm becoming more interested in and seeing change almost by the week. And I think it's really important when you come into weather and climate science, you really want to kind of look at what is changing. It's not just the climate, the technology is changing. And this is kind of before finalizing, is the world weather getting more extreme? Yes, we are seeing more extremes. Some of them are easier to attribute to climate change, but some things are also changing, like technology. We can become more resilient to changes in weather with a very powerful tool that is technology. So even though the world is changing, we do have very powerful tools which are now becoming more and more at our fingertips. And all this data I've been plotting, open source data. Again, I'll have references, and if anybody would like a copy of the presentation, definitely happy to share it. So that's me just about to wrap up, so I'll pause it there, but would be happy to take any questions. The graphic there is the average temperature 1750 to 2020 for Slovakia. So that's where we are. Thank you very much for your time, and thanks for listening.
Thank you, Scott, for this full-scale planetary picture, what is going on, and what can we expect. And now there is a space for some questions, if coming. Oh yeah. How do you get a consistent data set of ocean temperatures from 18th century?
So that's a good question from Anonymous. I think when it comes to creating reconstructions, there are things we know that we can directly measure. So we've had thermometers throughout the World Meteorological Organization has had very long-running temperature data sets which we've had access to. When it comes to ocean temperatures, there are reconstructions we can create using computer models. There are past data sets, including ice core data, sea level data, carbon dating. There are things that we can look at in the past which can tell us more about it. There are obviously large gaps in some of the data reconstructions there. There are areas of the world that were shaded in grey. You can't know everything, but yeah, there are some gaps in the data, but there are definitely things we can do with current trends and be able to work with that data.
Okay. We know that actually each scientific process includes a certain level of uncertainties. How should we handle this uncertainty regarding the climate change? Because the skeptics, in many cases, emphasizes these uncertainties, and they are telling us it's not wise to take any decision because the uncertainty is that big that we do not have a clear picture what to do.
I think when it comes to uncertainty, there's an uncertainty in everything when it comes to life. I think when it comes to what we're doing here today and being well prepared for a decision, I mean, skeptics, one word for it, but being inquisitive and being your own detective when it comes to data. I think being able to look at the data for yourself and see what's going on and being able to ingest that data and make your own decisions, I think that makes the whole operation of communication and decision making much smoother. So I think it is good to be inquisitive. I mean, there are uncertainties, but when it comes to things we know, the clear trends, there are things that are much easier to say about larger, broader scale facts. And I think that's the kind of main takeaway. You can always go down rabbit holes and look at alternative like ideas and stuff, but when you always kind of zoom out and look at what we know, I think the message is quite clear.
Yeah, I can remember about 20 years ago, and that time still some physicists denied the climate change. It's not here. It's wrong measurement, wrong data, and so on. Now we do not see any such opinions and expressions from the scientific society. Well, and what about the artificial intelligence? It can help us in many cases to resolve the scientific issues.
Great.
But can it help us to express and to explain, to communicate this issue to people? How does it work? How this should work?
I mean, I'm not an artificial intelligence expert, but I'm seeing more and more of it, and the amount of data it can process and use and give us past patterns and give us something meaningful as a result is becoming more and more of a part of weather forecasting. I think weather forecasting itself could really start to change with artificial intelligence, and I think it also brings in other people who have a different area of expertise to start looking at problems in a different way and using other sources of data and even starting to connect things that you wouldn't know there'd be an impact in some part of society, some part of the world. I think AI can help us prepare for changes in some things that we might not be able to see if we kind of look at it from more of a typical human approach, I guess.
Okay, we'll see the technologies. And in your opinion, what are the key indicators in human fingerprint on climate change? What are we doing bad?
The key fingerprints on climate change, I think we kind of covered that in the topic there. Well, what's changed? The fingerprints are like, well, what's changed in our atmosphere and oceans? Well, the thing that's changed, first of all, in the atmosphere is the amount of greenhouse gas in the atmosphere and how that's then kind of translating into impacts on temperature on a larger scale. And that's what we're seeing. So like vital signs, what I've been kind of talking about throughout today, kind of going back to kind of looking at this as a patient who's just said, well, let's see what's going on. I think when you talk about what things have been changing in our past, what's been changing the most, what sort of impact is it having, and this is what sort of result.
Yes, we are visibly contributing to the climate change, but do you think we can somehow stop it?
Sorry, say it again?
If we can stop the global warming.
So that, unfortunately, it's not an overnight solution. So the amount of warming that we've seen in the atmosphere, there's going to be a knock-on impact on the ocean. So even if we manage to stop carbon emissions overnight, there would still be impacts as we go through. But it's about what we do today, which can impact further down the line. So that's where I think, again, communication is quite hard to kind of make things meaningful if it's actually something that can still happen even if we stop. So that's another source of kind of action that's pretty difficult. But yeah, can we stop it? Well, we can certainly limit the impacts.
Yeah, so it looks like our generation and the next generation will have to live with the adaptation to the climate change rather than to stopping it. It's not that easy.
It's not easy. I think, well, again, technology and looking at things in a kind of very open-minded way and using new tools and kind of away from what we're using as current methods, I think there are different ways of being able to handle it, and I think the future has obviously its challenges, but there are things that we can look at, and there are opportunities.
All right. So the last question: what do you think is the most important regarding the handling and the solution of climate change?
So yeah, that's a good question, and it really depends who you ask, where you're from, and what you're looking at. So in my opinion, when it comes to making meaningful decisions, is really understanding what is going on and being able to believe and not believe. That's not even the right word. Is fully understand it and then take the right decision. For example, going back to this example in North America, New York's about to have a flood tomorrow. How do you make somebody pack up their bags and say, like, this street is going to be floating with cars tomorrow? Like, being able to tell that in a way that's clear, calm, and well communicated, I think that's where one of the biggest challenges lies. And I think that's where there's still quite a lot of work to do. There's a lot of science that's moving forward, but I think there's still, to get the really meaningful decisions and actions, it's about getting it in an absolutely calm and crystal clear way. That's it.
Okay, so thank you very much, Scott. The time is pressing. The organizer is pressing.
Thank you.
It was very nice having you here. You could experience Slovak climate, which is not that much different from European climate. Thank you very much to you as well for following us and watching us. And probably the climate will not change that much. It should be as stable as the change. Thank you.
Okay.